This is a final, just brief video on drawing structures. So there's do's and don'ts. Start with some of the do's. So methane, for example, we look at like this, typically drawn. Only notice this is drawn without any geometry to it. And we pointed out that an equivalent way to draw this that's more descriptive is with a wedge and hash mark. The wedge being forward, hash mark back. So if you were to build a model of it, you would realize that these are in plane or in the plane of the paper. This is back and this is forward. And that describes much better the 3D geometry, which is, of course, tetrahedral. Made the point several times of how the geometry will relate to behavior, activity, reactivity. Often in the drug world, it's how a drug binds to a larger molecule, like a receptor, based on its geometry and bonding principles. So, very, very important concept. We don't always have to draw atoms in. Often they can be implied. So another equivalent way to draw this is like this. Notice the carbon is not drawn, but just implied. Now, if I was to draw this, that would be a different molecule. Why? Because at each of these positions, here, 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 and here would be an implied carbon. So that molecule, in fact, would be this molecule. What you want to do is do enough homework practice problems, and of course watching videos and reading the book. Draw your structures according with what you see in those sources, rather than trying to make up your own version of any of it, which happens a surprising amount of the time. So here we have the carbon in the middle here implied, the others drawn in for clarity, but really these two are the same. And so another more accurate way geometrically, we could go back to this version, and again this is the same as those. So moving on, some more do's. Say we have a molecule like this, oxygen. Notice that I didn't draw in the lone pairs. The lone pairs are implied. What else is implied in this structure? The fact that there's a CH3 group here in this position, a CH2 group there, a CH2 group there, a CH3 group there. So a lot is implied in this. The oxygen, however, you have to draw in, otherwise we don't know there's an oxygen there. But a lot of times the lone pairs are left out. So if I was to draw this more fully, I could draw it like this. And notice I always draw, if I remember, the bond going from carbon to carbon with the 3 hydrogens off to the left. And I'll change the position of those hydrogens if it was off to the right. Which I'll do on the other end of the molecule. I could draw in my lone pairs to remind myself that they're there. Those lone pairs are reactive. That's probably the most reactive portion of this molecule. And then see the methyl group here. I have placed the CH3s, the H3, the 3 H's off to the right, because it makes me uncomfortable to see this bond between oxygen and carbon looking as if it was, for example, like this. Oops. You know, this looks really weird to me. Okay, get rid of that for now. Another important part is if I was to draw this showing geometry, right? I'm still having everything implied except notice what I decided not to have implied. That's because this is really the only part of the molecule here where there's anything of interest going on. This is a functional group, an alcohol group. It's the only part of the molecule where a reaction might take place for the most part. So, and it's the only part of the molecule that has geometry of any kind of interest. So it'll often be drawn like that. Look how long it takes to draw it out fully. A lot of what we do is to avoid having to do this every time. Look how long this is taking. You know, so we don't want to have to do this every time. And in fact, I could have even put wedge and hash mark here, here. I didn't draw these out fully, in fact, consistent. So I wasn't consistent in how I drew this. So try to be consistent in how you do it. But mainly we do it this way for time saving. I'd ask you to consider this molecule. And again, the reason why we use the wedge and the hash marks versus this molecule. Notice all other atoms implied. And even then it takes a while to draw. I want you to build a model of this if you have your model sets. Hope they're required, actually. And convince yourself that these are different. This could be a difference that's very important in the reactivity of the molecule. I'll leave that one as is for you to consider. Okay, so the don'ts. Again, don't make up your own system. If it's not in a book, in the notes, in a video, in an official source, it's not a real system. And it can be very wrong or very deceptive. For example, I've seen this. Okay? Don't do that. I've seen this. Again, what's this space here? What this implies is a CH2 group right there in that position. Don't do that. I have seen this. Don't want to do that. I have seen this, for example. So there's nothing wrong with the OH group. We need to show OH groups like this if they're present, but this is incomplete. And it's, I guess, understandable. It's a little strange at first. It's like, well, we know the hydrogens are implied at all of these, but when you start out by drawing the carbons as not implied, it looks really strange to not have the rest of the hydrogens in there, the full complement. So this was incomplete, and now it's complete. So don't do it that first way. Here's another one. Again, this is incomplete. If this was drawn as is, I would assume that it has a negative charge on the oxygen if there's no hydrogen attached or anything else attached to this oxygen, because there would be 3 lone pairs implied, and oxygen is +6 from the periodic table, minus 1, 2, 3, 4, 5, 6, 7. That oxygen has a negative formal charge. So it was an incorrect structure as drawn initially. It would be correct if it was a minus charge on there. Or if the person drawing it meant to draw this, that would be correct and no charge. One more example of something like this. Here's a ring. If I was to draw this like this, that again would be incorrect because that nitrogen has a plus charge. So without the plus charge, it's incorrect. It's an incorrect structure. So people will lose points on these various kinds of things, saying, well, I drew everything that was there. It's like, no, the charge is part of the structure. Always remember that the charge is part of the structure. Okay, this was really just meant to be a brief video. It went a little longer than expected, but anyway, we're going to move on to Module 2 here shortly. And don't forget, homework due Wednesday.